Hello, quantitative literacy friends out there. We're going to play around with lesson 4.5, breaking down variables. So here we've got this crazy formula for the braking distance d of a car. V is the velocity. Note, velocity here is in feet per second. Usually we do miles per hour, so I have to do a little conversion. This is kind of like that formula for blood alcohol percentage after drinking an alcoholic beverage. We have all these variables that come together to help you figure out what's going on. Same thing happens here. So we have a few different variables to deal with. So d is our braking distance based on the speed or velocity in feet per second. G is the roadway grade, and we talked about that before. And so that's a percent. It's got to be written in a decimal form. And the coefficient of friction, there's lots of experiments people have done based on the type of road and the type of tire to figure out how they interact together when you try and stop and go into a skid. And so here we have a note that good tires on good pavement provides a friction coefficient of about 0.8 to 0.85. And then this little g here is the acceleration due to gravity, which is what gives things weight. So we have to take that into consideration also. So that's part of this formula. And so we're just going to play around with this formula, plug in some stuff in, and make a spreadsheet and see what happens. So I'm going to jump over to a spreadsheet here. In this formula, we're going to let f be 0.8, and g is going to be 0.05. So a very mild grade, 5% grade. Actually, that's not very mild. 5% grade is pretty good. So let's see what we can do. So we're going to build this table right here in a spreadsheet. So if you haven't already, get yourself a spreadsheet or watch this and then try after. So reproducing this, I'm going to have a column for velocity. But I think before I do that, I'm going to enter my formula. So d is equal to the initial velocity squared. So I'm just going to write that as a big V raised to the second power. And then we're going to divide that by a big denominator, so I'm going to put parentheses. In the denominator, I'm going to have a 2 times little g, and then that's going to be multiplied by another parentheses, where we take the friction coefficient, and add it to the road grade. Those two combined have an effect on the stopping. And then close the denominator. Put some spaces in here to try and make it a little more readable. So that's our formula in a straight line. All right, so then I want a column for velocity. And the first velocity is going to be miles per hour, the way we're used to thinking about it. And then we do velocity in feet per second, which is what the formula needs. So feet per second. And then we'll use that formula to calculate the braking distance. And if the velocity is in feet per second, then we'll get a braking distance in feet. Okay, and we were asked to do this for 10 miles per hour. I'm not going to type the units because I've already noted them above. And 20 miles per hour, and 40 miles per hour, and 80, and then we can do some more if we want. All right, so other numbers that I'm going to need, we could type them over here. We are going to say little f. Maybe we'll put it over here. Little f is going to equal 0.8 friction, as noted above. And then what else do we have? We have big G, the road grade. That equal to 5%. And let's just clean that in here. Make it pretty. All right. Calculating feet per second. So let's write that down. So if somebody gives me a starting point of 10, I'm going to write it as miles over hours, so 1 hour. I want to multiply by fractions so that I can get rid of miles and hours. My goal is to end up with a fraction that has feet over seconds. So converting miles, I have to multiply by a fraction with miles in the bottom. And I know that there's 5,280 feet in a mile. So this fraction here tells me that to do this conversion, I'm going to have to eventually multiply by 5,280. So that's going to get rid of miles and leave feet. So I'm partway toward my goal. Getting rid of hours, since it's in the bottom, I'm going to have to multiply by an hour factor on the top. And I know minutes in an hour. I can't remember how many seconds. There's a lot. So in 1 hour, there's 60 minutes. That gets rid of hours, leaving minutes. I'm almost toward my goal of seconds in the bottom. One more fraction should do it. Minutes is in the bottom, so we put it in the top to get rid of it. I know that there are 60 seconds in 1 minute. And now minutes is gone, and I've reached my goal of feet per second. So this sequence of multiplying fractions says to take 10, multiply by 5,280, then divide by 60, and then divide by 60 again. So let's ask Google what that is. And so off to the side here, I can write convert, and we're going to take, for example, 10 times 5. Why am I doing it there? I already got a place for it over here. Sorry. We're going to take our 10 right here, multiply it by 5,280, divide it by 60, and divide it by 60 again. And that tells me 10 miles per hour is about 14, 15 feet per second. Now, my formula here only relies on the amount of miles per hour in the next cell, so that's ready to fill down. So I can just grab that and get the velocity in feet per second. For 80 miles per hour, it would be like 100 and almost 120 feet per second. Braking distance is where I got to do my crazy formula here. And other things I need to know are little g was given in the previous worksheet. That's the force due to gravity, and in feet per second, that is 32.2-ish. That is feet per second squared, feet per second squared. And we'll talk more about that later. Prettier, and prettier, center you. All right. So braking distance, according to my formula, over so I can see it, equals velocity squared. So grab your velocity and square it. And then divide that by this complicated denominator. Complicated denominators have to go in parentheses. And it says take 2 times little g, which is this guy over here. And then we're going to multiply that by another parentheses where we add little f and big G. Right? Little f plus big G. So then click and plus and click. So then I close the sum and then I close the denominator. If I don't close those in the right order, I won't get the right answer. So I'm pretty sure the braking distance for 10 miles per hour is about 4 feet. And I don't need all these decimal places. Let's clean that up. So we can reduce the amount of decimals to, let's say, 2 should be nice. Now, I can't fill this formula down yet, and here's why. Although the velocity changes each time, little f, big G, and little g are fixed. And since I'm copying this down, when I copy it down, the computer's going to want to change the B3 to a B4. That's okay. But it's going to want to change E3, gravity, to E4, which is a problem. So I need to sneak in here and throw in some dollar signs to say, hey, for gravity, don't mess with row 3. For friction, don't mess with row 1. And for, what's that, the road grade, don't mess with row 2 there. Sneak in my dollar sign so I get absolute references there. The only variable really here, since we have a fixed grade and a fixed type of braking surface, is the velocity. And so now if I fill it down, it should change appropriately. And just double checking that last one, I should see it grab the new velocity and then it uses the other fixed values over there. And so I can pretty quickly calculate all the numbers I need there. And we can also add extra information. So for example, if somebody says, well, what if you're doing like 65 miles per hour, you're on the highway, then I can come over here and say, okay, fill down the formula, 65 miles per hour is going to be about 95 feet per second. and the braking distance for 65 miles per hour with good tires on a good road on a slight slope is about 165 feet. Some other things we could mess around with. Let's focus on that 65 for a minute. Let's highlight that. Suppose someone said, well, it's actually a level grade, so we can make G 0, and it's going to take longer to stop. The 5% grade means I was going uphill. If I was going downhill, I could do something like do negative 5%. So if I'm going downhill, it's going to be harder to stop. It's going to take longer. Make that back to 0. But if it was a rainy day, if it's a rainy day, the road's going to be slicker, so the friction coefficient could drop down to like 0.5 instead of 0.8. And then it's going to take me like 300 feet almost to stop. So this is kind of cool. We can experiment. This would be a really good thing to show new drivers to say, hey, be cautious, don't drive too close to somebody, and consider your speed when you're doing that. And this also, we can play around with different road conditions, and that's what the friction coefficient lets us do, and the road grade. Kind of nice. Force acceleration due to gravity. Oops, I typed the wrong number there. 32.2-ish. Change the numbers a bit, but not that much. Gives me those there. So not too bad playing around with the spreadsheet. So we can answer all kinds of questions by playing around with different road conditions, with F and big G there, and different velocities over here. So like we get to play with the blood alcohol percentage equation, this equation, which varies depending on a bunch of different stuff. We can totally explore with a spreadsheet and get lots of good information. That's it for now. I hope you're all having fun and doing good math. Take care.